Hello everyone, welcome to my class. In previous lecture, we have learned about process life cycle. Like a human, a process has a life cycle. A process is created by its parent process, and it is running its job using various system resources such as CPU resource and memory space, and it is terminated normally or abnormally by several events including hardware exception, software exception, and user interrupt. At the beginning in its life, the process inherits various properties from its parent process. However, it wants to be independent. Today's topic is program execution. We will learn exact system call and library functions to replace the inherited program by a completely new program for the independent life. As you can see, there are two parts, top and bottom. Top is about process creation, and bottom is about program execution. Let's see the top first. Step 1. A parent process wants to make a new child process. So, the parent process requests the kernel to make a new child process using the fork system call. Step 2. The kernel creates a new memory space for the child process, that is to say, the memory duplicate of the parent process. The child process inherits parent stack segment, parent heap segment, and parent data segment. The program code can be shared by the two processes. Step 3. The child process can execute a different set of functions in the same program code as the parent. Until now, I described the procedure of process creation, step 1 and 2 and 3. Now, let's see the bottom. There is another step 3. The child process inherits most of the parent's properties. However, the child process does not want to receive the inheritance from the parent. It wants to be independent. The child process uses the exact VE system call to load and execute an entirely new program. Step 4. Following the exact VE system call, the kernel removes the inheritance from the parent, and then the kernel loads a new program into the memory of the child process and creates a new stack, new heap, new data segment based on the code of the new program. From this point, the child process is completely different from the parent process. Now, the child process is completely independent. How can I use the exact VE system call? We need the Unix system.header file. Exact VE system call has 3 arguments. The first one is path name, the second one is argument value, and the third one is environment point. Path name means where to get the new program. Argument value means information you want to pass to the new program. Environment point means environment information you want to pass to the new program. Path name must be a binary executable or an interpreter script. For more information, refer to the link, the manual page. Let's click and access this site. This is Linux manual pages. It's very useful for you. Let's read the sentences that seems to be important. Name, execve execute program, synopsis, and description. Let's read these sentences. Execve execute the program refer to the by path name. This causes the program that is currently being run by the calling process to be replaced with a new program with newly initialized stack, heap, and data segment. Path name must be either a binary executable or a script starting with a line of the form, like this. Argument value is an array of the point to the strings passed to the new program as its command line arguments. By convention, the first of these strings should contain the file name associated with the file being executed. The argument value array must be terminated by a null point. Environment point is an array of the point to strings, conventionally of the form key equal value, which is passed as an environment to the new program. It must be terminated by a null pointer. Okay, and then read this sentence below. Execve does not return on success, and the text initialize data, uninitialized data, and stack of the calling process are overwritten according to the contents of the newly loaded program. Okay, until now we have read description part here. Let's summarize. You can see the definition of the execve system calls, and then the execve system calls has three arguments: path name, and argument value, and environment point. Path name means where. Actually, you have to indicate where is the program. That is necessary, not optional, because the kernel have to know where the program is. Okay, the new program must be a binary executable files, not text file. And then the argument value means data or information that you want to pass to the new program. Environment point means strings in the form of key equal value. It is also data or information you want to pass to the new program. Let's see the example below. You can see the two programs. One is my echo.c, the other is execve.c program. Let's see the myecho.c first. It is very simple, as you can see, because just one printf functions. Printf functions just echoes each command line argument using the for loop. That's it. And then next, execve.c program. This program has two variables. One is new argument value, the other is new environment. In here, you can see the data format of new argument value and new environment. New argument value is an array of pointers to strings: null, hello, world, null. It starts with null and ends with null. New argument value must be terminated by null point, like this. Next, new environment variables is also an array of points to string. Each format is key equal value, key equal value. However, in this case, there is no new environment, so it ends with null point. This part is the error handling code on command line argument, and argument value index number 1 means the second argument value. It is assigned to new argument value index number 0. In here, by calling execve system call, a new program that is argument value index number 1 will be loaded with new argument value and new environment. What is argument value index number 1? This one. And this one is from the command line argument. At the command line interface, we will call myecho program as a new program. For more understanding, let's see this line. /execve /myecho. This one is argument value number 0. This one is argument value number 1. This is going to here, and going to here, and going to here. Okay, that's it. Next is exec library functions. As you can see, there are several exec library functions, which is almost same function, that is program execution. They are based on execve system call. However, they have different arguments, especially the first argument. For example, execl function has path name and argument list. In here, L means argument list. execv function has path name and argument value or argument vector. In here, v means argument vector. In this case, vector means an array of pointers to strings. execle and execvpe functions have additional environment point. In here, E means environment point. execlp, execvp, execvpe functions have file arguments. That means You can specify just the name of the file to be executed. How can the functions find out the file? The functions make use of the path environment variable to find out the file to be executed. In here, P means path environment variables. For more information, you had better refer to the link manual pages. What is path environment variables? You can see the value of path by typing echo command and $path in the command line interface. The value of path is a string consisting of colon-separated directory names. For example, /sbin : /bin : /usrbin : and so on. When you log in to the system, the value of path is set by the startup shell script. That is to say, your shell script has the path environment variables. When you run a program on the shell interface, the program, that is, process, inherit a copy of the shell's path environment variables. In conclusion, all of the child process inherit a copy of the shell's path environment variables. Therefore, we can use the path environment variables in the exec functions when you execute a new program. Next is practice time. Practice makes perfect. This time, we will implement a new program named myShellCommand using fork, execute, wait, and exit system call. In command line interface, we will run the program by typing /myShellCommand, and then, as you can see, command colon will be displayed waiting your commands. In here, you will type pwd, for example. pwd means display your present working directory. And then the following outputs will be displayed: parent PID, child PID, your present working directory, status, and so on will be displayed. And then command colon will be displayed once again, waiting your another command. Okay, until now, I described the overall input and output of this program. Can you guess or implement this program? How can I implement this program? Let's see the step-by-step procedure. This step-by-step procedure will help you understand how to create a process using fork system call, how to execute a new program using execute system call, how to wait a status of process using wait system call, and how to exit a process using exit system call. Step 1. Fork system call. A parent process wants to make a new child process. So the parent process requests the kernel to make a new child process using the fork system call. Step 2. The kernel creates a new memory space for the child process, that is to say, the memory duplicate of the parent process. The child process inherits parent stack segment, parent heap segment, and parent data segment. And the program code can be shared by two processes. Step 3. The child process inherits most of the parent properties. However, the child process does not want to receive the inheritance from the parent. Therefore, the child process uses the exact library function to load and execute an entirely new program. In this case, the new program is shell command. Step 4. The kernel loads a new program into the memory of the child process and create new stack, new heap, new data segment based on the code of the new program. At this point, the child process becomes shell command. Step 5. The parent process can obtain the status of the child process using wait system call. The parent process is always wondering if the child process is terminated by signals or itself. This is a pseudo code when you are using fork exec wait exit system call. First, we declare child PID variable and status variable. Child PID variable will contain the return value of fork system call. Status variable will contain the status of the child process. According to the result of the fork system call, there will be three cases: -1, 0, and default. Case -1, error is occurred, so we have to handle the error in this case. After the fork system call is running, 0 is returned for the child process. So the child process will be executed this part in case of 0. The PID of the child process is returned for the parent process. PID is a positive integer value, so the parent process will be executed this part in case of default. At this point, the parent process is waiting the status of the child process using wait PID system call. In conclusion, case 0 is called for the child process. Case default is called for the parent process. Okay, until now, I described the overall pseudocode using the fork, exec, wait, and exit system call. From now on, we will implement the program using Visual Studio Code. Practice makes perfect. Follow me